We're looking at another critical subject, which I think some people haven't really thought about, because water is very cheap in Malaysia. That's why rainwater harvesting hasn't really taken off. But if we think about the fact that, you know, the water pipe from Pahang to Selangor is supposed to be, after initially being budgeted at 4 point something billion, latest cost estimates are close to 10 billion. That's the true cost of water supply in Malaysia. And if you calculate 28 million Malaysians, most likely taxpayers' money will have to be used to construct all of these things. So there are a couple of hundred ringgit each of you is going to contribute to that project. So, you know, rainwater harvesting, nobody is interested in it because water in Malaysia is so cheap. But the true cost of supplying the water costs the country an arm and a leg. So I want to know what is the latest on that in Malaysia, because if we would be able to harvest a little bit more of that huge amount of rainwater, I'm sure the country could save a lot of money. And we've got an expert for that subject. We've got Engineer Haji Mohamad Fauzi bin Mohamad from the National Hydraulics Research Institute in Malaysia. He was born in '59 and holds a diploma in civil engineering, a Bachelor of Science in Civil Engineering, and a Master in Hydrology and Water Resources. He is a professional engineer, member of the Board of Engineers. He had served at JKR from '83 to 2001, massive amount of experience, before serving at the National Hydraulic Research Institute of Malaysia from 2001 to present. At JKR, he held the position of Senior Executive Engineer before serving at the National Hydraulic Research Institute as a Senior Researcher on Coastal Engineering from 2001 to 2003, and Director of Hydraulic and Instrumentation Laboratory from 2003 until now. He has vast experience in project management and structural design with a major in coastal structures during his tenure at JKR. So a big welcome to Engineer Haji Mohamad Fauzi bin Mohamad. Welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Professor Zairi, NAHRIM, and thank you very much for the very extensive or comprehensive introduction of my experience and also my education background. So we have just now listened to this source of the energy into the buildings. So my paper this afternoon will be on the actually the research experience on rainwater harvesting, basically done in my institute of research, NAHRIM, and as well as maybe in the country. So this the outline of this of my presentation as shown on the slide would be, I will actually skip on the country profile, but will touch a bit on the water resources status, water resources issues, and overview of the rainwater harvesting system, and the experience, research experience on the rainwater harvestings, and way forward, and as well as the conclusion. So this one, just skip it, and then and as well as this one is just a figure from the National Water Resources Studies on the quantity, volume, and availability of the water in the countries. And now I'd like to touch a bit on this driving forces and pressure on the water resources, whereby the pressure on the water resources would be due to the natural condition and as well as the humanity actions. And the main driving force on the water resources are the growth, population growth, particularly in water shortage regions, major demographic changes as people from the rural migrates to the urban environment, as well as the high demand for the food security and as well as social economic well-being. And the competition between the user and the usage, and another important is on the pollution from industrial, municipal, and as well as agriculture sources. And not to forget is on the climate variability and changes. And afterward, I think we can listen from our moderator is himself, Mr. Green Matthias, will touch on the climate change topic and the issue of the water resources in our country. Basically, our country, as first few slides, we have plenty of water resources, excesses of water resources, but at times we have shortage due to the drought condition, and the main issue here on the water are the pollution, as well as the coming on the climate change issue will affect and will influence on the water resources. The water access. We are very fortunate. Our quantity, water quantity is very high, but unfortunately, the 60% of the rainfall, the annual rainfall, that means the quantity of water, occurs between November to January, and this causes the flooding to the coastal areas, and also to the riverine areas. And 9% of our country, 9% of the areas of our country flood prone areas, and shows on the on my right the photos of the flooding. And the threat, the biggest threat for this heavy rainfall are actually the flood event. If from this statistic, we have the disasters from 1965 to 2007. We have list of disasters: drought, epidemic, landslide, wildfire, windstorm. But the most critical are the flood occurrence, which affected from 65 to 2007 more than 1 million population, and more than 30 events in over the period. And also the problem of the water shortage, which occurs severely in the small state area, Malacca, Perlis, and Pulau Pinang, whereby the drought period extended and caused the water supply problem to these states. And on the water pollution, the issue is on the for the point and non-point sources, and from the study, the waste dumped into the Klang Valley, from the Klang Valley into the rivers. Statistic shows that 60 tons of the waste was dumped daily into the Klang Valley. And also from our study shows that out of the 90 lakes and reservoirs, 90 lake and reservoirs are anthropic, that means polluted due to the fertilizers and pesticide. So this will impact the countries, the cities, agriculture, and also land clearance, which will cause influence on our water supply. So on the climate condition. From the studies in our country, the increase in the temperature for 1993 to 2003, 3.1 mm per year, and also on the sea level rise also shows the increase from the record 0.2 mm to 4 mm per year. And the runoff volumes for the selected drainage system from the previous study, we have 150 billion meter cube of water, and the future estimated 159 billion meter cube of water. And this some comparison between the historical and future water availability from our study that we carry out, whereby the blue is the future runoff and the green, the red colors is the historical runoff. And then we found out that certain areas will be facing less water quantity of water. For example, in Terengganu, Dungun, and Johor, and as well as in Selangor. So this one I have a dimension on the projected climate change and overview. Now I come to the overview of the rainwater harvesting system. I think this rainwater harvesting system is actually a very basic methodology, and being traditionally used in our kampung-kampung, in villages from the very old days, and I think also until today this rainwater harvesting is being practiced. Okay, a little bit of the background for the rainwater harvesting. In 1998 we experienced a very bad drought, which so many people, especially in Klang Valley, in Malacca, were affected by this condition, whereby they are facing the disruption of the water supply. So this undoubtedly created a surge of interest in rainwater harvesting, and following that, in May 1998, Ministry of Housing and Local Government has expressed the government interest for houses to be designed to include facilities for collecting rainwater. And in June 1999, Ministry of Housing and Local Government has come up with a guideline on the installation of the rainwater collection and utilization system. And in 2007, our National Water Resources Council approved the usage of this rainwater to be practiced, and then the guideline will include the regulation, guideline and regulation of the building planning to in this building planning to include the rainwater harvesting. So I think most of our present here architects, they are more aware on this regulation, and the review and the review of the rainwater harvesting system guideline was produced by the Ministry of Housing and Local Government. And also the government carry out the conservation awareness campaign, water conservation campaign, and a comprehensive action plan by the ministry to make sure that rainwater harvesting can be implemented effectively and extensively. And further to that, the government didn't stop at that point, and in November 2007, cabinet meeting agreed to make installation mandatory to the new development. and in 2011 has approved National Council for Local Government approved the regulation in the building bylaw, and in November 2011 has gazetted, which requires new semi-D bungalows and government building to install rainwater harvesting system. And this maybe to date, unfortunately we don't have the data on the implementation of this rainwater harvesting system in especially in government building at least. And this followed by the 4 states gazetting this bylaw. Those states are Kelantan, Perak, Selangor and Johor, and also follow up by this Kuala Lumpur through the state local government authority. So these are the newspaper cutting which prove the requirement. New semi-D home bungalows and government must have green feature. That is one of the green features are the rainwater harvesting. Came out in the on 14th of June 2011, and as well in 2012 budget, the government has provided 20,000 water tank costing 52 million to Sarawak, which benefited 100,000 people. And this will expand, the program will expand to Sabah with allocation of 50 million. This statement by our current PM sometime last year. So the concept of rainwater, I think no need to elaborate further, because those are very basic, very basic. You know, collect the water from basically from the roof, or maybe from the the open space area into the container, and then traditionally they directly use the water like this one to supply the water to the cows, all those things. And these are another concept of the rainwater harvesting. And this one is also the similar thing. The rainwater harvesting capture the rainwater through basically the roof and into the tank. And the only thing is I wanted to highlight here is the rainwater harvesting system normally or maybe currently used for a non-potable landscape irrigation, toilet flushing system, maybe washing the cars and as well. But besides, the rainwater also can be used as drinking water, and as well as maybe can be commercialized as the drinking water with proper treatment. And these are the system for the rainwater harvesting. We have the roof catchment and to collect the water, and this has to go through the so-called the first flush system. With this first flush system actually to let go the the polluted portion of the rainwater from the roof, and then goes into the tank. And then if the tank is underground, then requires pumping. But if the tank is high enough, then no need any pump, then it can directly be used. And then the benefit, actually the rainwater harvesting is not only for the water supply, for this not only for the non-potable use. Besides the supply for the additional water, it can also serve as the flood prevention, especially at the urban areas, and also restoration of the hydrological cycle, alleviation of the heatland, control of non-point sources, and as well as prevention of the river, the dry flow of the river. And this is the example of the additional water sources, whereby the rainwater are collected for the use of the industrial and also the domestic. Normally this is being collected on the roof, and for the prevention of the urban flooding, the installation of the rainwater at homes or building, which will help to reduce the runoff. So if in a very large quantity in one, let's say the housing estate, let's say all the houses, individual houses, collect the rain water, then it will definitely reduce the runoff into the drainage system during the storm, and thus reduce the occurrence of the flash flood. For the purpose of hydrological cycle, restoration of the hydrological cycle, the water which collected can be released. The collection and release of the rainwater during after the rain can improve the soil permeability, and as well as subsequently will improve the groundwater system. And then for the alleviation of the heat island, the rainwater pouring on the hot and dry ground can reduce the heat on the earth surface, and as well as maybe on the roof, the green roof, which use the rainwater to water the roof, and also maybe the plant on the roof. This also will reduce the heat island impact. And for the control of the non-point source, the concept of rain garden, is introduced, whereby this rain garden can be used as a filter of the pollutant coming down from the upstream into the drain, being filtered by the rain garden, and the outflow from this rain garden has gone through the filtration, and clean water will pass through. And this basically very close to our concept of SMA that being implemented by the idea, the MASMA. And then for the prevention of the dry stream, the rainwater can be collected and only be released downstream during the dry periods to maintain the quantity of the water flowing through the river. And now only I go to the research experience in rainwater harvesting. So we have carried out the research in one of the terrace houses, whereby from the data, and then the collected, and then the result or the research being carried out in this double-story terrace, whereby the rainwater is used for the toilet flushing, general cleaning, and the occupants of this terrace house with 6 people located in Wasa Malawati, Kuala Lumpur. From the data and also the study that we carry out, it shows that 30% of the household water supply required from the public source can be saved. 34% is considered quite high. And then this is the I think the famous one Utama shopping mall. They utilize the rainwater system for the toilet flushing and as well as the cooling system, tower cooling system, and then they can save 30% of the water bills. And if I'm not mistaken, they recover the cost, capital cost for these facilities. I think we have here, I think within 1 or 2 years they recover the capital cost, capital expenditure of the providing these facilities. Is very I think worth to invest. Bram-Prai courthouse, the harvested water also used for the flushing of the toilet, save up to 15 days with the capacity of 44.5 meter cube. And this is for the industrial water cool plant. Toilet use the rainwater for toilet flushing, garden watering, as equipment cleaning, filling up the cooling towers as well. And they can save up to RM 800 to 1,500 per month based on the current tariff. And just now is for the and now for the water shortage prevention, we carry out the the rainwater harvesting for the longhouse in Sarawak, by longhouse in Sarawak, to supplement the existing river water supply. And this one we designed to achieve a 21 days water supply duration. Currently they are getting a 21 days water supply duration, and we are monitoring the system there, and then the reliability of the rainwater harvesting over there is 85%. These are the photos showing the tanks for the rainwater harvesting at the Bai Longhouse Sarawak. And also we have here the details. I think that this white in color is the pipe into the tank, and this is another view. Actually, after the phase 1, we improve the system to supply 30 days. Before it was 21 days, and now for the phase 2 we upgrade and increase the capacity up to 30 days water supply system. And also flood reduction at the community level. We also carry out the study how the rainwater harvesting can influence the flood condition. So the same location in Taman Wangsa Malawati, we carry out the study, and from our study, if every resident, shop lots and public buildings install these on-site detention and plus the rainwater harvesting system, the possibility to achieve the 50% reduction in the flood control is actually a very significant in reducing the flooding. Now is we are carrying out the study to look at the reduction of the flood reduction at the catchment level. So as shown here, we are assessing the catchment level to study the reduction in the flood on the in using the rainwater harvesting. the finding from this study, we found out that the occurrence of the flood rainwater at each building, we managed to reduce from the for the 800 AI 14 event to 8 event, and so on. And the frequent, the very frequent one actually very significantly reduced for 5 years return period. Without the rainwater harvesting, the occurrence 9, and then with the rainwater harvesting reduced to only 1. So the similarly to the 2 years occurrence ARI. And also in our complex, we actually also practice the rainwater harvesting system, where we utilize the rainwater for the toilet flushing, and as well as the uses in our modeling, physical modeling lab, whereby in our physical modeling lab we use a lot of water. So we harvest the water and use during our experiment and testing in our lab. And the reliability from our study for on the rainwater harvesting is estimated at 90%. These are the building, the administration building, and this is the lab building. And the rainwater being used in the toilet, and as well as the lab facility, whereby for the lab experimental purposes, we collect the rainwater into the pond, and then from here we pump into our storage inside the lab, and by gravity transfer it into our facilities for the experiment purposes. And also the rainwater harvesting being implemented at the National Zoo to supplement the water supply for the use of this two hippo ponds. We supply supplement the supply for the public toilets, and also the two hippo ponds. And the reliability is 70%, and the saving from our calculation, we managed to save around 830 ringgit monthly. And also another rainwater harvesting project that we carry out is this is for the most in Taman Bukit Indah Ampang, whereby we construct the rainwater tanks just underneath the parking area, and the rainwater is being used for the toilet flushing in the masjid, the mosque. So those are the list of the rainwater harvesting projects that we have in NAHRIM. And for the future research, we can look at the more on the management and the utilization of the master plan, whereby if we compare currently, once the rain come down and directly flow into the river, then which the river couldn't take the quantity because of the very fast flowing, especially in the urban areas. Whereby all these concrete jungles are there, whereby their retention of water are very low. And then if we introduce the detention pond, this can help can help and reduce the flow directly into the river, and which will in result can alleviate the flooding problem. It's a similar thing. Currently these are our practice, whereby we when the rain comes and directly enter into the river, but if we practice using the cycle here, it may help alleviating the flood problem beside the water resources, water supply. Comparison, another graphical comparison between the conventional, whereby water will directly goes into the drainage and fill up the drain pipe, and if we use this storage pump, it can help to reduce the capacity of the storm water drainage, and finally will help in alleviate the flooding. And another study that we carry out is for this area, the Sungai Bunus area, whereby we are studying the possibility of using the rainwater harvesting to alleviate the problem of flooding. And from our calculation, these are the rainfall data, and then from our calculation, from the data, industrial, the land use data, industrial, and also green area, and also this industrial, as well as this as well as the tempat untuk home place, and then we calculated the quantity that can be saved, and this the results that shows we can help it can help the flooding of the area. So in conclusion on the rainwater harvesting, this is essential for the future sustainable development of the city, and also it can the system can be developed using the cheap and efficient technology through further research. And rainwater harvesting is a sustainable approach that can be very cost effective in the long term, and the utilization of the rainwater should not be restricted to supplementing of the water supply alone. Besides, it can be, as I explained, as a flood reduction, and as well as the rainwater harvesting in response to the extreme ultimately enhance the resilience of the human resources due to the extreme climate. As we are aware now, is the issue of the climate change. And lastly, the research and development on this the rainwater harvesting for different purposes and activities are very important and must then be carried out. With that, thank you very much for the listening.
Thank you so much, Engineer Haji Mohamad Fauzi, for this very relevant and interesting presentation as well. So the floor is open to our audience, questions on the presentation, on the paper, on the rainwater harvesting. Maybe I can kick it off with what is the main reason that so far rainwater harvesting in Malaysia, its uptake is fairly limited, and what was the cost per person for the system you installed in the longhouse in Sarawak?
The main reason I think because the water are very cheap in our country. So, and then people are not willing to invest because if you want to introduce new things to your maybe your properties, your buildings. For the rainwater harvesting system, we need what? At least the pump, at least the water tank. Maybe most of our houses we have gutters, but we don't have the water tank. So at least the water tank. This water tank, maybe the issue is the space. If you have a very limited space, water tank, maybe if you need to construct to provide the water tank underground, then it will incur additional cost. Maybe that is one of the reason. The main is because of our water rate is considered cheap, and especially in Selangor, we have 20 meter cube free of water. So that is my opinion. In my opinion, and for this buyer long house thing is very basically is a what we call a community project. So we didn't really calculate the cost per head. So, but basically I can maybe let you know the overall cost of the project.
I mean, that would be interesting to see how commercially viable it is, but then on the other hand, in a remote location, you don't really have the infrastructure to supply the clean household type water.
Yes.
So you can't really compare anyway. Similar with solar. If you want to install solar systems in a remote location where you don't have a grid and people use diesel generators, even though your solar cost 1 ringgit per kilowatt hour, is still commercially viable, no problem, but not in central KL. So questions from the audience on the rainwater harvesting?
Thank you very much.
Yes, the gentleman here in the front row.
Assalamualaikum and very good evening. I am Hazel Mansour from University Tun Hussein On, Batu Pahat, Johor. I would like to, not question actually, but maybe sharing ideas or opinion, maybe between others, because I'm not people in the field in rainwater harvesting system, etc. And then since the participation from house owners is not so delightful, and then why not PBT play a crucial role on preparing water trap and ponds, and then because learning from water system in Japan, especially in one water bills every month they have 2 items. One is the water from the conventional water supply, and another one is the treatment water. Why not we in Malaysia, using the privilege of in Malaysia we have heavy rain rate for Khatulistiwa. Using that privilege, we had good system of water trap by PBT and supplying that water to each maybe smaller project houses as a start. And we bill with two items on one bill to the each houses or each project. Let's say the conventional water supply 2 ringgit per meter square, and the rain harvest is cheaper, maybe 1 ringgit per meter square. Just an opinion and discussion, open for discussion. Thank you.
Okay, thank you for that contribution. What do you think?
Yeah, I think it's a good idea, and because from my earlier slides, I'm actually going through the. We have a sort of in sometime in 2011, the National Council for the Local Government actually has approved a regulation for the uniform building bylaw. Two, we should require these semi-D houses, bungalows, and government buildings, at least to start off, to kick off using the rainwater harvesting system. The only thing, unfortunately, maybe CRIM has the data on the usage up to date. What are the percentage, especially for the new buildings. And the idea just now more actually on the government side to come up with the rules or regulation. But it's to me it's okay. It's a good idea, and I agree with that.
Yeah, I guess what you're proposing would assume that somebody invests in a rainwater harvesting system and then charges less for the semi-free rainwater. But the problem is in Malaysia, the treated water is already so cheap. Nobody will want to invest. Where are you going to get the money from? You can only invest if you promise a return, unless you've got some charity that wants to pump billions and billions into this without ever getting a serious return.
Yeah, I totally agree with you, but thinking of flash flood and so on, there's so much money spent on it to make a new water trap and so on. Why not beginning with this governmental action on making trap pond and so on, so we'll be well provided rainwater, and also we will become flash flood, any anti-flash flood activities. I don't know, maybe. Thank you.
I think in a way you're right. If you would take the 10 billion from the water pipe, Pahang to Selangor, and then the money that's spent on flash flood, then we could possibly implement rainwater harvesting systems all over Malaysia. Yeah. But it's politically a very hot potato, you know, and everybody has to promise to make electricity and water cheaper and cheaper, even though economically, you know, it will make Malaysia struggle in the future. But there we go. I mean, what can we do? What is realistic? I'm looking to our guru here.
Oh. I think more on the, just very short comment, is on the policy.
Policy, yeah.
And this is more influenced by the
political
by
decision making.
The government.
I think you're right, because but I would suggest one good thing, one good example that doesn't hurt any political parties that need to get votes, could be, for example, to make it mandatory based on your research results.
Yes.
Flood-prone areas, any developer doing residential development needs to have a mandatory installation of rainwater harvesting system to reduce the pressure on flooding. So that would make sense, right? Everybody in theory could agree to it. And if you know that area is flood prone already, then even the buyers of houses should be happy to pay a little bit more, because it should help them to not face the floods. I mean, yeah, the research results are very clear here, but then to get the policy implementation support, that I guess will be the problem.
Maybe in the government also should look into the incentives to the developer, or, who's going to introduce the rainwater system in their development project. Some sort of incentive.
Okay, anyone else with a comment or a question on the rainwater harvesting issue, or any suggestion how we can increase rainwater harvesting in Malaysia, the country of so much rain?
Yes.
And so much water coming from the sky, a country perfectly destined to be very successful with rainwater harvesting, but unfortunately in reality, what to do lah? I think we have some statistics there, right? Annual rainfall volume 990 billion cubic meter. Wow. That's a lot.
Yes.
How much do we consume per year?
I think these are the figures.
Mm.
You know, around what, 15,000
That's in million
liter per day.
So the actual consumption is a small fraction of the water coming down.
Yes. Only basically what, few percent.
Yeah, few percent.
Less than 5%.
So it's all there. Mother Nature provides for it. But yes. So maybe we have an unsolved question, but isn't it mandatory in Selangor now for certain houses to install rainwater harvesting system? If I remember that correctly, I read that in the paper. Or is that not yet?
For the semi-D
Semi-D.
and bungalows.
Semi-D.
Yeah,
And bungalows.
Yeah.
Yeah. Okay. So I think for me the conclusion is this should happen in Malaysia. It should happen. It must happen sooner or later. Otherwise the country will lose a lot of resources. You know, what I always think is people who want to increase inefficiency. And Malaysia, I only know the statistics for electricity. I read Malaysia consumes 40% more electricity than neighboring countries.
Even the water, so our rate of water usage per day is I think around 220 liters per person, as compared to our neighboring around 150 something.
Wow, so similar. So Malaysia is 40% consuming 40% more water and electricity. I would call it not consuming, I would say wasting. We are wasting so much. I mean, my electricity bill is 20 to 30 ringgit a month, so I guess I'm not in that category of wasting, and my water is minimal as well. My shower is like, you know, switch it on, make yourself wet, switch it off, soap a little bit, rinse, that's it, job done. And I never use hot water to save electricity. I never switch on the water heater. So those are some of the small, let's say, practical things on a daily life that we might to do. But yeah, if Malaysia doesn't become more energy and water efficient, a lot of money is going to be drained out of the system.
Yeah,
and people think it's good for them not to pay a lot for water, but it increases inefficiency, and then the general pot, some taxpayers' money or whatever else, or Petronas gas money for the electricity has to be used to subsidize. So the money has to come from somewhere.
It's very, the real example is our smart tunnel.
Smart tunnel, yeah.
Just to divert the water. The water. It's not to use the water. It's to divert. We spend billions.
Yeah.
Just to divert.
Yeah.
So just imagine the amount that we spend.
So I think the conclusion from this session is the evidence is there, the research evidence, it works as a system for the house. It works to alleviate the risk of flooding. It can be applied in remote location. All the expertise is there, but is still not happening at any significant stage yet. So we need more political support and enforcement. Maybe make it mandatory for certain areas, otherwise it might never happen. That's the gut feeling I have. I don't know whether you support that, but
yeah, I share.
Yeah. Okay, good. So thank you very much for a very comprehensive and excellent presentation. A big applause.